Hey, Mr. Keller, I'm doing corrections for exam 9A. So we start off with number 3 right here. And so the correct answer was B. And the answer is because the wheel is spinning clockwise. So it's going like this. So it's spinning into the page. And since that part is spinning into the page, the angular velocity is in the opposite direction. So it's spinning out of the page. So the answer is B. Okay, and then we move on to number 4, where you're looking for the rotational kinetic energy and the angular momentum. And so you basically just have to do 2/3 mr squared. And after you find I, which is from, well, you find I from 2/3 mr squared. Once you get I, you do I omega squared, and you are given omega, which is 45. And so you get 5.16, or close to it, which is close to 5.115, which is the first part of B. But then, in order to find the rotational kinetic energy, or the angular momentum, I'm sorry, you just do I omega. And so you're just doing 0.0051 times 45, which equals 0.2295, which is close to 0.2273. So I said the answer could be B. Okay. Move on to number 6. Number 6. Two solid discs begin spinning in the opposite direction and are brought together. And so you're looking for, well, you're kind of taking into account the friction, or the angular momentum. You're looking for the angular momentum. So you do, you find I for both of them. So you use 1/2 mr squared. And so you get 3 for the 6m cylinder, and then you get 8 for I of the 4m cylinder. And so for the 6m cylinder, you do I omega, so you get 6, and then for the 4m you do you get 24, and then you do 24 minus 6 to get 18 18 omega, which is the total for both of them together, because it's a collision. And then so you get 18 omega, and then you find 11 you get 11 because the total of the i's, 3 plus 8 is 11. Okay, and then for 7, you're looking for the new angular velocity. So you're just doing you're basically just doing I omega initial equals I omega final. And so you get 2/5 mr squared, 2/5 m 10r squared, omega initial equals 2/5 m 9r squared omega final. And so you can cancel out the 2/5 m because they're the same on both sides. So you're stuck with 10r squared omega initial equals 9r squared omega final. But the 10r squared is 10r squared quantity. So you're squaring both the 10 and the r. So then you can cancel out the r's after you do that, and then you get 100 omega initial over 81, because then you have to divide this to get omega final by itself. So the answer would have been D. And then for number 8, her rotational inertia should have decreased if she pulls in her arms, because she's spinning faster. So it's the opposite. Okay, and then we move on to number 10. And so number 10, originally I thought you were supposed to find whatever the 1/2 mv squared was, or mr squared was, whatever the first one, but you actually look of what the coefficient is to the mr squared. And so for an ice block, there is no since it doesn't spin, there's no energy given off, so that's 0. So A was definitely the first one, and then you just go down the list of the least. So the order was A, B, E, C, D, and that's because in this equation you do potential equals linear kinetic, which is this would end up equaling like mr squared omega squared, and so you cancel off the m's, and so basically you would just come up with the coefficients. So the answer is A. Okay, now we move on to 11, part B. And so on part B, you're basically just doing K equals 1/2 mr squared, but then you need the additional v squared over r squared, and so the r squareds cancel, and then you're just stuck with K equals 1/2 mv squared. So that's the answer. And then for part D, what distance will the hoop roll along the incline? Since you know this from part C, now you're trying to find this right here. You're trying to find the diagonal. And so originally your equation is sine because you have opposite and hypotenuse. So sine is opposite over hypotenuse, which is this over, and this is x. So you get v squared over g over x. But since you want to find x, you do it all out and you get x equals v squared over g sine theta, which is the answer. And then we move on to 11e. 11e, I got the third part wrong, which is increasing the steepness of the incline. And that has no effect on the height because you're looking for the vertical height, which doesn't actually matter if it's steep or not because you already have theta. And so if this stays the same, doesn't matter how steep this is, doesn't matter what theta is right there. Yeah, and it's dependent on the v squared over g, and since this is constant, wouldn't have an effect. And then for 11f, you are looking for the maximum height that the hoop reaches on an incline, and since it's frictionless, that means that it doesn't stop spinning. So that's why you need kinetic energy right here, but you also need the rotation, but then you also have potential energy, and you have this. But these two cancel, the 1/2 I omega squareds cancel, so then you're just stuck with